Assalamu alaikum. So today we are going to discuss about the confidence interval for mean and rate differences. So before we begin, things we need to remember are what is confidence interval 95% means. It means that if we perform any essay 100 times, we should be confident that 95 times our experiment data will yield the same calculated value within the expected range. And the other fact we should remember is that it only conveys the effects of sampling variations on the precision of sampling estimate, but it has no significant on sampling error. So let's say, for example, if we are dealing with the assessment of lung cancer, but we are collecting the data of all the patients who are visiting the hospital. In that case, the patients who are coming to the hospital are already biased in terms of smoking habits. So, confidence interval doesn't deal with that initial notion of sampling error. If we are talking about the habits of lung cancer in the general community, and the patients or the clinics we are seeking are explicitly addressing the smoking habits. Now, the confidence interval doesn't deal with that initial sampling error or biasness on both on the behalf of investigator or the design. Okay, so it is just that what we are dealing with is the confidence we are achieving on different levels, 95, 90 or 99%. So let us calculate the confidence interval of a mean height of a class. So suppose, and this is just a general way of writing confidence interval 95%, lower level and higher level. So the data we have about the class is that the number of individuals enrolled in this class are 30. Mean height is 165 centimeters, that's the mean height, and the standard deviation we are expecting is 7.1. So with a brief calculation, we are going to estimate the first and foremost value would be the standard error, that is SD standard deviation, that is provided as 7.1 centimeters divided by the square root of 30, number of individuals. So by putting all these values in the formula, we are going to get a value that 162 centimeters to 168 centimeters is the confidence interval limit thresholds. So the lower level and the higher levels are written over here. So I want you to practice the same thing for the confidence interval of 90% and 99%. I am providing you the answers in this regard as well. The first one, the formulas are written over here. So keep doing it and have a practice about it, and then let me know whether your answers tally with the reference or not. So this is how you calculate the confidence interval for mean values. But what about if we are interested to know the confidence interval of rate differences? For example, if we want to know that the persons who are dealing with a certain kind of disease are related to any occupation. So in a cohort study of 15,326 men employed in a factory, their cancer mortality was assessed in relation to the duration of the employment. And now we want to calculate the confidence interval in context of duration of their service in the factory. So the story cut short is that the duration of employment is variable. Now, some of the employees have a service duration less than 1 year. Out of those employees, the number of cases reported are 44. The person's year is 456. So the rate of the mortality is calculated as 11. That is actually dividing 44 by 456. Now, the incidence rate for employees working will be calculated using the same formula. The rate difference, if you see on the right side column, that is rate difference confidence interval 95%. So let's assume the example of the individuals who have worked from 5 to 9 years. There are 48 cases. So the incidence rate calculated is 95. The range, the rate difference is 84. This 84 is actually derived by subtracting 95 minus 11, the 11 from less than 1 year of exposure. So this is the rate difference confidence interval, 95%. And then for estimation, the formula used is given over here. So confidence interval for rate difference is equal to rate difference plus or minus 1.96 into standard error of the rate difference. So the standard error is equal to R, that's the rate value, divided by the square root of A. Now the square root of A over here is 48. The rate value we have, R value, rate value is equal to 95, as we have calculated over here, the 95. So standard error is presented with the and is calculated over here. So once we have added the values, we are going to get lower and higher levels over here. What I want you to do, class, is to calculate rate difference confidence interval 95 and practice to achieve these values of confidence interval rate difference values, okay, so that you can estimate and you can judge yourself how to calculate the confidence interval at 95% for this example. So the people are having a job and they are exposed to a particular type of disease after a certain period of time, and we want to know what is the likelihood of that disease, how long they are in a profession and they are going to get a risk about any disease. Okay, so that's what I want to infer from this data. Now, another way to present this data of rate difference confidence interval 95% is generally to make a graph. Now, the rate difference is presented over here in the form of 95% confidence interval over here with the duration of employment provided over here. So this is the mean rate difference, and with the mean rate difference presented over here, this is the confidence interval variations. Now the confidence interval variations, that's the lower level, this is the highest level, as you can see from the bars, and you can present this data that the person who are working less than 1 years of employment are relatively more safe as compared to the other ones. Now, this is another example. This is pretty straightforward and simple example. In Pakistan, 39 individuals died of HIV infection. Total study duration was this much persons year. Calculate the rate. So for rate estimation, it's pretty straightforward. 39 divided by the denominator value of person years, and calculate 95% confidence interval for HIV mortality. Okay, no problem. So this is the rate estimation we did. Confidence interval, the same formula, standard error of rate. So for rate, the value has been calculated 2.24 divided by the square root of 39, and then we are putting up these values to match our score of confidence interval. So this confidence interval of 1.53 to 2.95 is providing us a value that every time we have some HIV mortality, the values variation will exceed from 1.53 to 2.95. This is the level of fluctuation, and this is the value we are getting for HIV exposure in Pakistan. Thank you very much for your time and attention. Hope you like the video, and keep watching. If you have any questions, please feel free to ask.